Now we're going to see another example of simple exponential smoothing, but we're going to look at it from a very practical point of view. So here we have observations of weekly sales for WFJ for a total of 62 weeks. Okay, since we have 62 weeks of sales, what we can do is we can split the sample data into two parts and look at one part for analyzing and coming up with a model, and then we'll apply the model that we develop from this sample to the holdout sample, the sample that usually the later part of the sample. We'll use that as a holdout sample. And we apply the model to the holdout sample and see how the holdout sample performs, how the model performs with the holdout sample. So this allows us to actually judge how the model will perform with data that was not part of developing the model, because after all, in forecasting, we're going to be forecasting a future where the model was not developed using the data that's going to come from the future. So we are kind of simulating the future by simply not considering some of the data in the data set and using them as a kind of a simulated future values, and then see how the model that we developed from the first set of the sample data performs in the second set of data, which stands in for future data set. So here we're going to look at the first 26 weeks as our data set for modeling, and then we'll use those, and I'm going to first illustrate how the model that we develop here can be applied to compute forecast from 27 to 36. But in fact, what we want to do is to take the model that we develop using data from 1 to 26 and actually develop forecasts for the holdout sample, which is 27 to 62, and gather accuracy measures for the holdout sample. Okay, so that's what we're going to do now. So we'll start with setting the model up for the analysis data. So this is the first set of the sample, the analysis sample set. Let's start with, let's say we assume a trial value of 0.2. Obviously, we're going to be analyzing the value of alpha and see the best value of alpha that that we will be using. The best value for alpha that will give us the minimum MAE value, and we're going to use the average of the first 5 weeks as the starting value for forecast. So that will be the first forecast that will be available to us is in week 6. Okay, we're going to say the first value, the initial value. Okay, we're going to use the 5th value, forecast for the 5th week, as the initial value for F, and that will be the average of first 4 weeks. So that's the that's what we are assuming. So here this will be the average of the first 4 weeks. That will be our initial forecast. So our initial error will be the actual minus this forecast. So now we have a forecast and an error. So let's make that like that. Okay. Then we set up the formula, which will be the previous forecast plus alpha. You need to make that absolute reference. Alpha times the error. Okay. And then the error for week 6 will be that. So now we can copy. Okay. So we are only using the first 26 rows to develop the model. Okay. So now we can set up the error measures Okay, MSE will be MSE. Okay, and we want to use starting from week 6 to week 26. So week 6 through week 26, and the forecast is week 6 through week 26. So that's our mean square error. And then we use RMSE of the same set. And MAE. And then MAPE. MAPE is a percentage, so let's make that into percent. Then MASE will be the actual value range and the forecast we're considering. Okay. Then the random walk forecast. Random walk forecast will be the forecast for week 6 would be week 5. So week 6 through 26 will be week 5 through week 25. So that will be our MASE. Okay, so now you see that it's not performing better than random walk until you, the same thing, actual Y range, forecast Y range, and random walk forecast range, which is 5 through that. So once we have all of this, then we can run solver to find the best value of alpha. Okay, so we'll go data solver. Now let's say we want to minimize RMSE. They are all MSE, RMSE, MAE, MAP. They're all very similar measures, so you can choose any one of them actually. And we want to minimize, and we want to do that by changing alpha, and we want the alpha to be less than or equal to 1. Okay, and it is non-negative. So now solve, and we get a solution and says alpha is 0.728, and for that we get least MAE of 2367, 7.2% MAPE, and it does a little bit better than random walk. So the best SES model is better than random walk model, and we need to reserve judgment till later because this is the model that we developed using the data. Now we have to see how this model will perform with respect to future data that we have reserved for analysis. So now we need to take this model and apply it to the future data set, simulated future from 26 to 62, and then see what the error measures will be for that simulated future weeks.